Good day everyone! Welcome to my YouTube channel. I'm Gulay Jennylyn R from BS Math 1A. Please to subscribe and hit the notification bell button for more upcoming videos. In this video, we will talk about skewness in relation to central tendency. Previously on DIS, we've already talked about the measures of central tendency. Now, let's have a quick review about it. Measures of central tendency, also referred to as measures of center or central location. It's a summary measure that attempts to describe a whole set of data with a single value that represents the middle or center of its distribution. Its goal is to find the single score that is most typical or most representative of the entire distribution. Unfortunately, there is no single measure that will always produce a central or representative value in every situation. Thus, we use its three main measures, which are mean, the average, the sum of all values over the number of values in a data set. Second is the median. It's the middle value of an ordered data set. And the third is the mode, the values that occurs frequently. Let's consider this example to get the mean, median, and the mode. The salary of 11 people in a fast food restaurants are 10K, 11K, 12K, 10K, 10K, 13K, 14K, 16K, 16K, 13K, and 14K, respectively. To get the mean, we have the formula. It's EX over N, or the summation of all values, which is equal to 139K divided by the number of values, which is 11. And therefore, the mean is equal to 12.6K. For the median, we have to arrange the data first in ascending or descending order depending on your preference. In a distribution with an odd number of data, like for the example given, the median value is simply the middle value of the data set. Therefore, for our example, we have 13K as our median. On the other hand, when the distribution has an even number of data, the median value is the mean of the two middle values. In our example, the two middle values are 13 and 13. Divided by 2, therefore the median is equal to 13K. To get the mode, we can see in the table that the most frequent value is 10K, which has a frequency of 3. Therefore, the mode is 10K. Now, let's talk about skewness. What is skewness? Well, it is a measurement of the distortion of symmetrical distribution or asymmetry in a data set. Note that skewness is not the outlier, nor does not inform on the numbers of outliers. Rather, it only communicates the directions of outliers. Now, how does the shape of a skewed distribution influence the measures of central tendency? There are different types of skewed distribution. Consider the first histogram given. Histogram A shows a perfect form of a bell shape. Clearly, it's a symmetric distribution having the line in the middle. Notice that the left side is basically identical to the right side. So does this make the distribution symmetrical? Meaning, it's also a normal distribution wherein the mean, median, and mode are all equal and have a zero skew. You can use any of the three main measures of central tendency when a distribution is normal. For example, the weights of an 8-week-old puppies are shown in the histogram given. Notice that in a symmetrical distribution, the mean and median and mode are all equal. Therefore, the puppy's mean, median, and mode weights are all equal to 150. The histogram B, we notice that the tail is going to the right side of the distribution. Therefore, the distribution is said to be skewed to the right or known as positively skewed. In a positive skewed distribution, the mean is the largest while the mode is the smallest. And in this case, the mean is greater than the median, while mode is lesser than the median, or we can say that the median is greater than the mode. For example, the Coke sales in first 5 months of the year was shown in the histogram given. Notice that the mean of a right skewed distribution is almost greater than its median and mode. In our example, the mean number of sales in first 5 months was 300, which is greater than the median of 250 and mode of 200. The last histogram, the histogram C, clearly shows that the tail of the data is on the left side. Therefore, we can tell that this particular distribution is skewed to the left or called as negative skewed. In a negative or left skewed distribution, the mean is less than the median and they are both less than the mode. For example, the histogram for the number of reactors in negative skewed distribution shows that the mode is greater than the median and the mean. Therefore, the mean is 6, median is 7, and the mode is 8. In a skewed distribution, the mean and the median both reflect the skewing, but again, the mean reflects it more so. Therefore, in a skewed distribution, it is preferably safe to use the median as the measure of central tendency, as it is less likely to get affected by the outliers. Now, let's learn the basic differences of the two skewed distribution, which is the positive skewed and the negative skewed. Right skewed is also known as positively skewed. In the relation between right skewed histogram, mean, median, and mode is mean is greater than the median and median is greater than the mode. The peak of the graph lies on the left side of the center. While left skewed histogram, or also known as negatively skewed, the relation between mean, median, and mode in the left skewed histogram is mean is less than the median and less than the mode, and the peak of the graph lies on the right side of the center. In conclusion, skewness in relation to central tendency plays a vital role in the real world, as it helps us identify where the average or mean, median, and mode lies in a skewed distribution, allowing us to know if it is a negative or a positive skewed. It is also significant in the areas of statistics, business, education, even in sports games, etc., as it provides us direction where the outliers lies in our distribution. Now for the exciting part, let's have a quick quiz. Based on the picture given below, what is true? Thank you for watching and listening. Hope you've learned something. Bye!